Hello, this is Michael with the Clearview Library District, and welcome to an online edition of The Works. The Works is for kids ages 6 to 12 who like to tinker, build, get messy, and explore, and it's a way for you to engage in science, technology, engineering, art, and math, or STEAM. Every other week, I'll have a new project for you to try at home, and I'll be focusing on a different part of STEAM learning every week. This week, what we're going to be doing is exploring some technology and a little bit of art, which is a really cool combination, I think. And please note that we'll be offering a limited supply of kits for the works. You can pick it up the previous week to when we release the episode on YouTube every other Thursday. So you can check our calendar at clearviewlibrary.org, search for the works, see what's coming up that week, and click on the event and you can check out what materials are included in the kit, and you just might have some of that stuff at home. If not, you can call the library or drop by and see if you can pick up a kit for the works. So today what we're going to be talking about is binary code and ASCII code. And these are two of the building blocks of everything that is a computer. All computers send information or data to one another, and they communicate all throughout our lives in different ways. And the base building block of data and how a computer reads it and looks at it and stores data is using binary code and ASCII code. So binary code is a base 2 number system. So that means it's only composed of two numbers, 0 and 1. And using a combination of zeros and ones, you can create any other number that we know of. So it's a long string of zeros and ones, which the computer will then read. Basically, the 0 is off or the 1 is on. You can kind of think about it. So if you think of electronics, a transistor will read with no electricity, it will be off, so it'll be a 0. And once electricity passes through it, it would read 1 as in on. So in this way, you can kind of represent numbers in different ways inside of a computer. And so it's still the primary language for computers because it's just simple to use, it's elegant, it only uses 0 and 1s, so the computer can read it quickly. And it's just the most efficient way for a computer to read information. So I'm going to share my screen and we're going to look at what binary kind of looks like and how to read it. Okay, let me find, here we go. So here's binary. You're going to start with just zeros representing the number 0. Now, each placement has a different value placed on it. So the last position on the furthest right is going to be 0. However, that's going to be the 1 position. So if it was a 1, we would count 1. So if this last kind of bit in this code was 1 on the furthest right, the binary code would be the number 1. So the next position over is the 2. And so we're looking at binary. Actually, the computer reads it from left to right, just like we read. However, the code kind of looks like it's applied from right to left, because right now, the only bit that is on in these 4 numbers is this position. So in binary, that's the second position, or the 2. So if that was on, the number would be 2. If both of the right numbers in the sequence of 4, 0, 0, 1, 1, if both of those are on, you're going to count them together. So this first placement, which is actually the last when we were looking at it, reading it from left to right, is on, or a 1, and the other one is on. The number 2 position is on. So that means we combine those two and it makes the number 3. So you go up in value until you have a maximum, and you can essentially count every number that way. Here's another way to look at it. So again, we're sort of looking at it from right to left, and we have 8 different numbers here. 0, 1, 1, 0, 1, 0, 0, 0. So in this first position, which if we read it the regular way we read it would be the last or the furthest right, but in binary it's kind of looking backwards at it. So this first digit is a 0. The second one is a 0, which is the 2's. The third digit here would be the 4's. And the fourth digit, we finally have a 1, which is on. So we would count that as 8. And we go along. This value is a 0, which would be the 16ths, but it's off, so we don't count that. The next one, the value is 32, and it is on, so we'd add that to the original 8. And then we have the 64 value is on, and the last one is off. So you would essentially read that 8 plus 32 plus 64, which would be 104. And so you don't count the bits with the 0, you only count the bits with the 1. And when we're reading it in binary code, this number, which is 0, 1, 1, 0, 1, 0, 0, 0, would actually be read as the number 104. Okay, it's pretty complicated at first, but if you look up binary code for kids in Google with the help of a parent, you will find some really good websites on how to actually do some of these lessons. Now we're going to get into what's called ASCII code. ASCII code is code for letters and how they relate to the binary code. So ASCII, we're going to basically convert letters into binary code zeros and ones, or we're going to use colors instead of zeros and ones. So here's a little key. Now in ASCII, you have different combinations of binary code for uppercase and lowercase letters. So keep that in mind. You can write your name in with the first letter uppercase if you want. Otherwise, we can just do it all in uppercase. And so what we're going to do, let me find my little map here. Must have lost it. Okay, that's fine. So ASCII code is just another way of reading letters and numbers. So ASCII is a set of letters, numbers, and characters computers use to communicate accurately. And basically, if you send information to another computer, this is how your computer knows what to display, because it gets this information in code, a series of zeros and ones, and it uses ASCII code to convert that into letters so you can actually read it. And so we have this code that converts those zeros and ones into letters, and thus we can kind of solve the code and actually read the message. So what you're going to have in your kit is 2 different colors of beads, and some of you will have 3 different colors, or you might have 2 different colors of beads, and then I put in some of them, some sort of sequins in place of beads. Now the reason is this: you're going to write your name out in zeros and ones, or this binary code, black and white, or different colors. So first, you're gonna write your name out. Now, if you run out of beads, what you can do is write your initials, write your pet's name, write your last name, whatever word has fewer letters in it, if you run out of beads for this. So you could pick a different word that's shorter if you want. And what you're going to do is write it out. So for example, if you run out of beads, what you can do is write your name out in zeros and ones, or this binary code, black and white, or different colors. So If we were going to spell the word cat, we would find the letter C, and this is the binary code for the letter C. And you're going to see it's going to be black, white, black, 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 white, white, or 0, 1, 0, 0, 0, 0, 1, 1, however you want to think about it. What you're going to do is pick out for the zeros or the black ones, you're going to pick out a color of bead. So if you have red and white, maybe the black one is going to be red and then the whites are going to be white. However you want to think about it. And you're going to put this sequence, you're going to lay it out. So it would be, if you're using red and white, it would be red, white, red, 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 white, white. And that would be the letter C. So whatever color of bead you have, you're going to use for the black, and you're going to use the other color for the white, and then you're going to lay it out. Now, there's another thing we have to think about, which are called delimiters. Delimiters are essentially the space in between each letter. So we know that there are 8 digits in each letter. As you can see, there's 8 different on or off. So you can either lay them out, the letters right next to each other with no space in between, and that's totally fine because we know that every 8 digits, it's going to be a new letter. So every 8 beads, it's a new letter. Or you can use the third color of bead or sequin as a delimiter or space to show you when the next letter is coming. And I'll show you here. So this example uses delimiters. So what is happening here? Let's start with this one. They're using this kind of clear bead as a delimiter. So they have 8 beads representing one number, then a space or delimiter, and then 8 more to represent the next letter. So they wrote their name starting kind of from the left with 8 beads. So that's a letter, a space, which is the clear one or delimiter, then the next letter with 8 beads, a space, 8 more beads for the next letter, space, and all the way through. So you can see this example, they did use a delimiter or a space in between each letter. You can decide if you want to do that or not using the third color bead or the sequins, whatever is in your kit. Or I've had some students use macaroni for the delimiter, just something different to show that it's a new letter. But you don't have to. If you don't want to use the space or the delimiter, you can just use 8 pieces of bead and then 8 more, and you know that every 8 is a single letter in our code. So I hope this makes sense. What you're going to do is write out your name, then write out the binary code for it using this cutout strip. Each letter, you'll probably need extra paper to keep writing it down. You're going to lay out your beads however you decide to. If you want the blacks to be one color and the whites to be one color, you can put a space at the end of each letter or not. And then you're just going to string it all together. And that is your binary code necklace. So I hope you enjoyed today's edition of The Works. If you have any questions, you can always call the library or email me at michael@clearviewlibrary.org. And thanks for joining me. We'll see you next time.